What's going on, Science 10s? We're talking about displacement time graph and velocity time graphs today. So a displacement time graph shows, or sometimes called a position time graph, or a distance time graph, I suppose you could say. It's a visual way of representing an object's motion. The slope or the steepness of a line indicates the velocity of that object. So we're going to take a look at a couple examples. The first one is describe what's happening to the motion of the following objects. We got a graph of an object here, and we think of it as like a car or something like that. And so what you want to do whenever you're looking at a graph, or for the most part whenever you're looking at a graph, is you want to try and focus on what's in the x-axis and what's in the y-axis. So our y-axis here, for you math people, is the vertical axis, and that's our position. So our position is just saying relative to some reference point. So if we had a map here, if we had a map and we had some reference point over here, we could say that an object is starting 10 meters in the positive direction. So maybe we'll call that right. So it's starting 10 meters away from the reference point. So our object A is starting 10 meters away from the reference point. And what we want to do is we want to follow its position over time. And so we'll say, okay, it's 10 meters at 0 seconds. And then, well, it's 10 meters at 1 second, and 10 meters at 2 seconds, 10 meters at 3 seconds, 10 meters at 4 seconds. It looks like it's staying at 10 meters the entire time. And so we could say, describe what's happening to the motion. Well, I don't know about you, but it doesn't look like it's moving at all. And so this object A, or the object, is motionless. It has no motion. Another way of saying it has no motion or it's motionless, we could say it's at rest. And so that's depicted in a position time graph. Whenever you have a flat line, that means its position is staying constant. If you have a constant position, that means you're not moving, and that means that you must be staying still or at rest. That's what we call an object that's not moving. Okay, let's take a look at another position time graph for a different object. So we've got its position and over time. So if we were like looking at a map again, if we had some sort of reference point here, that's the reference point, we say, okay, object B at time 0 is starting at the reference point. So it's starting right on the reference point. And over time, after 1 second, it's moved 10 meters in the positive direction, right? This is a positive and that's a negative direction on the graph. And so it's moving positive 10 meters. And then another 1 second later, so a total of 2 seconds, it's moved another 10 meters away. We're looking at this line right now. We're following that line, and we're looking at these points. Those are kind of the main things that we're focusing our attention on right now. So after 1 second, it's gone 10 meters. After 2 seconds, it's gone 20 meters. So it's gone another 10 meters and another 10 meters and another 10 meters, and it just keeps going. So it looks like this object is traveling 10 meters every second. So after 1 second, 10 meters, 2 seconds, 20 meters, 3 seconds, 30 meters. It's traveling 10 meters every single second. Another way of saying that is that it's traveling with uniform motion. So this object, the object is traveling with uniform or in uniform motion. So it is traveling and in a positive direction. We can see it's heading in a positive direction. Okay, so these are all the things that we could say about the motion of this object, but we're just trying to get a sense of what's going on. An object is undergoing uniform motion when the slope of the dt graph is straight. So if we had a distance time graph or a displacement time graph like this, So this object is traveling with uniform motion, but this object is not traveling with uniform motion. So the blue object's traveling with uniform motion. It's going the same distance every second, okay? But the green object's not. It's traveling slowly at first, right? A flatter line is a slower line, or slower object, I guess. So it's traveling with less speed at the beginning, but it's traveling with a lot of speed at the end. So this object, this green object, is accelerating. It's not important right now, but it's just something to keep in mind. Okay. So what's going on here? So we've got a position time graph for an object, this particular object. And we say it's okay, well, it's between 0 and 2 seconds. It's traveling with uniform motion, but it's kind of traveling slowly. So between 0 and 2 seconds. So it's traveling with uniform motion, but it's kind of going slowly, okay? Because it's kind of a flat line. It's a little bit of a flat line. Then between 2 and 4 seconds, the object's, it's still traveling with uniform motion. It's still a relatively straight line, right? So it's traveling with uniform motion. And it's traveling faster now because the steepness of the line, it's a little bit more steep. The slope is a little bit greater. And then between 4 and 6 seconds, what's going on with the steepness of this line? It's totally flat, right? So the object is at rest. Perfect. Fantastic. Now we're going to take a look at velocity time graphs or speed time graphs, and they're a little bit different. So the big difference between a distance time graph and a velocity time graph is the unit that's being represented on the vertical axis here. Here we've got velocity, and that's totally different, hopefully you understand, than distance or displacement. So velocity time graphs or speed time graphs show how an object's velocity is changing over a certain amount of time. Uniform motion is shown whenever an object's speed is constant or not changing. Thus, an object displays uniform motion whenever you see a flat or unchanging line on a VT graph. So describe what kind of motion is going on in the following objects. So we got object X here, and we say, okay, it's not position anymore, it's velocity. So how fast is it traveling? Well, it's traveling at 10 meters. Sorry, this is meters per second. So it's traveling at 10 meters per second. And then after another second, traveling at 10 meters per second. And then another second, 10 meters per second. So this object, its velocity is constant. And that equals uniform motion, because it's a flat line. Ooh, that's not how you spell line. Line. Now, let's take a look at the other one, right? The other graphs that we were just looking at. So a flat line for a velocity time graph, that is uniform motion. But a flat line, gotta wait for my computer to catch up with me. A flat line here on a distance time graph means it's motionless. So you have to take a look at what's actually going on in your graph, and you have to kind of think about it. If the distance an object has traveled is not changing, it means it's not moving, it's at rest. But if an object's velocity isn't changing, it's still probably, as long as its velocity isn't 0, right? It's still probably actually moving. This thing is moving 10 meters every second in the positive direction. Just because its velocity isn't changing doesn't mean it's not moving. Okay, all right. I've talked enough about that. I'm boring you right now. It's okay. It'll be okay. So again, velocity in meters per second. That's my bad. So let's take a look at the velocity time graph for object Y. So object Y, at the beginning, it starts out with a velocity of 0. What is a velocity of 0? What does that mean to you? Yeah. If it has a velocity of 0, that means that, well, it's not moving. And if it's not moving, it's got to be at rest. So at time equals 0 seconds. So the object is at rest. It's not moving, right? But then as soon as, as 0.1 seconds starts moving, and what's happening to its speed or its velocity? It keeps going up and up and up. So it's going slowly at first, slowly, and it's going fast, and then it's going really fast. So what's happening is this object is accelerating because this line is sloped in the positive direction. It's accelerating. This is terrible. This has got to be my worst writing of all time, but that's okay. Hopefully you get it. So this object is not traveling with uniform motion. At any point in time, is its speed staying the same? So between here and here, did it stay the same? No, it went up. Between here and here, the speed had to go up a little bit in order for, while the object was moving. So, okay, all right, perfect. So if the slope of the line is not flat, then the object's speed or velocity is changing. Okay. We say the object is accelerating in either the positive or negative direction. So a VT graph where the object's going like this, that's accelerating in the positive direction. A VT graph that's going like this, that means accelerating in a negative direction. And all that means is that it's slowing down, but I don't know. We'll get to it. We'll get to it later. That's okay. So it's whatever. It's okay. So let's take a look at this graph here, and let's see what's going on here. Is its velocity remaining the same? That's the question you want to ask yourself. Is its velocity remaining the same between here and here? No, it's not. So what's happening? It's going 0 velocity, and then it ends up going 2 meters per second. So it must be accelerating, right? Accelerating in positive direction. What about between here and here? What's happening? Well, that's a uniform motion. Its speed isn't changing, and same as here. Its speed isn't changing between here and here and here and here. Its speed is going 2 meters per second. If starts going 2 meters per second, ends going 2 meters per second, it's constant, it's uniform motion. Good, awesome. So accelerating in the positive direction, and this section is also accelerating in the positive direction. But what the heck is going on over here? What is going on over here? It looks like we're going really fast. We're going 4 meters per second, and then we start to slow down. And whenever our speed is 0, right here, we're at rest. So we're going fast, and then we're at rest where we stop. So we must be accelerating in negative direction. Hopefully, I don't know, hopefully that kind of made sense. What I would like you to do, hopefully is a pretty short lesson today. What I would like you to do is I would like you to take a look at the practice questions here. There's only 4 questions. I just want you to get a really holistic sense of what's going on. So identify the time intervals that the object is heading in a negative direction, okay? So I want you to kind of tell me what's going on in this graph, and then answer a couple questions about this graph as well. And check your answers to the key. Check your answers to the key that's posted in the filled out notes. Thanks. Have a great day.